Can you maybe share a little bit more of some of the results that you've seen by going through the process of trying to create these cattle to specification as opposed to number of days? Have you gone through that process long enough to
Oh,
perhaps share some of those results?
oh yeah, I've got a whole report, and I'll share it with you, Dave, that you can share with your listeners. But absolutely, put it this way: we've got statistics. I was going to say there's lies and damn statistics, but seriously, aggregated and been able to demonstrate what happens when if 200 cattle are delivered on day one, and then we do that comparison.
Mhm.
There's clearly a measured and valid savings around greenhouse gas reduction, CO2 reduction, and just consuming, just all of the savings. I've got that report. If you're interested, I can share that with you, Dave. Um,
Absolutely. I'd love to take a look at it. And if we can go put it in the show
yeah,
notes for the listeners,
yeah,
I'm sure that they would, there will at least
yeah.
be a couple of them who are, I'm sure would be interested to hear that. And Vlad is at the very top of the list of
Yeah.
people who will be interested to go ahead
Hey,
and read the
I'm
report.
with you.
Um,
Yeah. So
ab- absolutely.
I've got a couple of other projects that are related with the beef production. So my next project, if we want to talk about that, is what we call
Yes,
sustainable
please.
production, and this is the one where we've built the digital twin for a new
Mhm.
greenfield meat packing plant. And what's interesting about this approach, it really helps the investors and basically encourages early engagement with the EPC firms and general contractors who will effectively design and build the new facility. And I think that's very
Okay.
important. This is all about it's typically with big projects, it can be they'll define up front. This is going to be based on a certain budget. But if we get in
Okay.
early enough, there is opportunity to value engineer, and it's iron sharpening iron in terms of coming up with best practices. And I think that's one of
Mhm.
the attractive aspects of a digital twin. But let me just go a little bit more into details for that and why it's important. So let's look at the persona of the investor. We can not only simulate the plant layout, the line designs, but what they can do, they can also now look at the facility from a financial and operations perspective. And financially speaking, we can simulate the various production revenue streams that will be delivered by the production line equipment. And with that digital twin, we speed up and slow down the lines. So that's another interesting angle. We can simulate, which I just mentioned. I got a second example from my accelerator sensor supply from Australia. We can actually simulate smart meat quality sensor data. And I said I'll cover that in my next example. That will indicate basically what we're looking to do is identify borderline carcass grades and then really effectively apply an optimized refrigeration and storage regime for that individual carcass. Okay. We can look at the production line and individual OEM production machines and they're operating, and this is really interesting, they're state models. And we can predict the kilowatt energy consumption for the normally running state, as we were talking before. This can be aggregated to produce a line facility load profile that we can use to assess
Mhm.
the utility rates and the opportunity for behind the meter renewables. We typically use this data with and for Siemens, we typically will use this this data with our what we call our energy twin software. And this helps us design and
Yep.
size the behind the meter generation and storage assets for the production campus. And these assets could be solar, battery storage, recip engines, or fuel cells. So more importantly, we can also simulate the use of manual operations. I think I joked with you earlier this week. It's Barney Rubble and Fred Flintstone with a knife in most of these
Mm.
facilities. Not much has changed since the Romans.
Yep.
What we can now do with this digital twin software, we can simulate the use of the manual operations, and there's lots of them. And the what if
Okay.
scenarios for optimal plant throughput and production KPIs. Today, many of the plant processes still require that manual operation, particularly if you've seen
Mhm.
fabrication. And manual operation insight is helpful during going back to working with the EPC designers as they do the FEL2, FEL3 planning phase of the design. And so that's where I think it comes in real helpful. But then the value of the digital twin, it also continues when the facility's been built. We can use the twin in conjunction with, we refer to it as our optimize my plant application, which allows the plant
Mhm.
manager to make daily decisions based upon worker availability and the best deployment of resources for maximum daily operation impact. So I think that there's an example of how we're using these tools to basically, first of all, we have to build the facility and then find that it was built too big or too
Yep.
small. And we can look at For me, I think what's most interesting is looking at the OEM equipment, looking and then building up this on the electrical side, this load profile. And then how can you've probably
Hmm.
heard initiatives around peak shaving or peak shifting.
Yeah.
And you need this type of data. Otherwise, either you're going to measure it, energy management to be able to deliver to that. I've got a
Hmm.
final one if we want to go into it, which is my sustainable production example. And this is actually, again, using how do I facilitate intelligent operations? And this is really by leveraging
Hmm.
and bringing what I'd like to refer to as AI and machine learning to the packing plant. I just look at it, and we'll talk about futures later on in this conversation. But for me, I'm just amazed at what we're able to do with lasers and visual processing, three-dimensional cameras, and graphical processing units. But again, here in this case, here on this sustainable production. So I'm working with, again, my Australian smart sensor manufacturer, and I'm working with two of their plant sensors. I'll just talk about one right now. And again, we're leveraging the power of edge computing and AI machine learning and algorithms. They're able to measure and predict intermuscular fat and meat grade. I use a smart laser
Wow.
probe and our edge device at the hot box. The hot box is when the animal is basically, that's that first phase of breaking it down into primal cuts, for example. What we're able to do there is we can measure the hot carcass physiology, and we can assign a preliminary beef carcass meat grade. And so this is actually interesting because this can help the meat packers operations team to basically make some decisions about that. One of the key benefits is, as we identify this meat marbling grade at the hot box, is really to identify what we call borderline grades. Is it between prime and select, or select and choice?
Hmm.
And what we've discovered, and this is known as one of those sort of undocumented but industry tribal knowledge, is these borderline carcasses can be assigned a specific blast, chill, refrigeration regime. Because typically what would happen, animals slaughtered on a Friday, assessed on a Monday, so for 2 days of chilling over the weekend, they typically upgrade.
Hmm.
Well, the beauty is if we can identify those animals, we can then basically do a prescribed blast, chill, refrigeration regime to that half side, and it does upgrade. That's a $200 margin increase for the packer. That's pretty phenomenal when 6% of animals in the facility might be on that borderline. The other thing too is if we identify the animal as a select meat quality, we don't need to do anything special. We can basically chill so again, I'm making refrigeration savings.
Hmm.
So the animal and just move it straight out to the sales cooler and out for fabrication. Again, it's like using smart sensors and technology to basically make actionable intelligence at the operations level. And there's a whole host of other benefits the packer can realize from this. We can be looking at pH, we can look at color, we can identify dark cutters. There's a bunch of things that can be done here that could be beneficial. But it all starts off with having data that they never had in the past. And it's data coming, it's not a
Hmm.
4 to 20 milliamp analog signal or a 1 to 10 volt DC input. No, it's actually, laser feedback going through some really high end computing that's then tying that to a machine learning AI model and basically spitting out information that we've never had in the past. So I think that's very interesting. And just as a final piece, as we were discussing earlier this week, when we look at this architecture, I'd encourage your listeners to look at the Procter & Gamble, Jeff Kent. He's an interesting fellow. He did a presentation at the ARC Forum last year, talking about his team's experience and planned rollout of what he calls their operational intelligence program. And this program will introduce thousands of machine learning algorithms at the equipment level at 120 sites in 40 countries. So this stuff is real. It's making an impact. And I think the example I just gave you is one small step for man, one big step for mankind, or trotter kind in the beef business.